Hello everyone, welcome back to the channel. Today we are going to understand one important topic in thermodynamics. It is called the polytropic process. This process helps engineers understand how machines really work, like compressors, engines, turbines, and refrigeration systems. By the end of this video, you will clearly understand what a polytropic process is, why engineers use it, the formula, practical examples, and real-world applications. Let's begin. In books, we study ideal processes: isothermal, adiabatic, isobaric, isochoric. These are good for learning. But in real machines, nothing is perfect. Heat always transfers. Friction is present. Energy is lost. Leakage happens. So real processes are never truly ideal. Because of this, engineers needed a better model, a model that matches real conditions. This model is called the polytropic process. Now let's understand the meaning. A polytropic process is a thermodynamic process where pressure and volume follow one rule. This rule is written as P multiplied by V to the power N equals constant. I will repeat. P times V equals constant. Here, P means pressure, V means volume, N is the polytropic index. The value of N decides the type of process. The most important part is the value of N. Different values give different processes. If N is 0, the process is isobaric. If N equals 1, the process is isothermal. If N equals gamma, the process is adiabatic. If N becomes very large, the process is isochoric. And if N has any other value, then the process is polytropic. So polytropic process is not fixed, not limited, not strict. It adjusts itself to match real behavior. Imagine a pressure and volume graph. The isothermal line is smooth. The adiabatic curve is steeper. The polytropic curve lies between them or sometimes outside. The curve changes because the value of N changes. Higher N means steeper curve. Lower N means flatter curve. This shows how flexible this process is. Now let's take a real example. A compressor. Air enters at low pressure. Air is compressed. Temperature increases. Some heat is lost. Some heat stays inside. So is it adiabatic? No. Is it isothermal? No. Then what is it? It is polytropic. That is why compressor companies always mention polytropic index equals 1.25 or 1.3. This tells engineers how real compression is happening inside. Now let us see the equations. Temperature change, T2 divided by T1 equals V1 divided by V2 raised to power N-1. Work done. Work equals P2V2 minus P1V1 divided by 1 minus N. Pressure relation P1 divided by P2 equals V2 divided by V1 raised to power N. These formulas help engineers to calculate power, predict temperature, design systems, improve efficiency. Polytropic process is used everywhere. In compressors, in turbines, in gas engines, in refrigeration cycles, in power plants, in jet engines, in boilers and pumps. If gas is expanding or compressing, polytropic process is used. Why do engineers love polytropic process? Because it is realistic, flexible, practical, accurate, reliable. It fits real machines perfectly. Always remember these points. Lower N means more heat transfer. Higher N means better insulation. The value of N depends on cooling system, speed of compression, material properties, environment, design of the machine. There is no fixed value. Each machine has its own N. Let's summarize. A polytropic process is a real-world process. Its formula is P times V equals constant. Value of N decides everything. It connects ideal theory with practical machines. It is used in engines, compressors, turbines, and refrigeration. I hope now you understand the polytropic process clearly. If you learned something today, please like this video, subscribe to the channel, and share it with your friends. Comment below if you have any questions. And remember, understanding is more important than memorizing. See you in the next video. Thank you.